So in a previous life, I worked at a software company that built software for caseworkers in child welfare. So I was on their data science team. And I don't remember what exactly my team was doing at the time, but I do remember that we were looking in the data and we were seeing, we had like a bunch of children in our database that were older than their parents. And not only were they older than their parents, they were like a lot older than their parents, and they were like a lot older than everyone. And so when we actually looked at the birth dates, we sort of plotted them visually, we started poking around in the database, it was really easy to see what had happened, which was that there was a bug in our application such that when a caseworker entered a child's birth date, if they entered the year with just 2 digits instead of 4, we would not, prepend the century information on the front. And so everyone that works with data has stories like this. You expect the data to behave a certain way. You're sort of carrying around that latent assumption in your head, and that assumption actually turns out not to hold. So my name is Jane. Fast forward a couple of years, and I now work at 2 Sigma Investments. I work with very different kinds of data, and I'm doing very different kinds of things with data now. But I'm still spending a lot of time thinking about this problem, which is that we make so many assumptions about data, and we're really, really bad at validating those assumptions. So what were my assumptions in this little story? The first one, pretty basic. Children are born after their parents. And the second one is that, people can't live forever. There's an upper bound to how old a person should be. So if I'm looking at a child that's born in the year 8, not only am I concerned that they were born before their parent, I'm also concerned that they're really, really freaking old. And so, of course, these aren't the only things, that I assume about data. So what are the other things we generally assume? My assumption about the birth dates is getting at one of the most central ones, which is that we assume that the values in our data set are correct, right? They correspond to actual values in the actual world. Another one that's pretty common is that we assume that we're not missing any data. I think probably everyone in this room that works with data knows that that assumption gets violated all the time. Another one might be that we assume that records are unique. And the reason that this assumption is important is that, if you have duplicates in your database, that can interfere with things like headcount, which messes with budgeting, which messes with staffing. There's all sorts of problems that can come if you get your headcount wrong. And then finally, this sort of doesn't apply. I don't think I really ever carried this assumption around when I was working with child welfare data, but let's say you have data coming from a sensor, you might assume that that sensor's measurements are precise. And so what that means is that if you take multiple readings from that sensor, the measurements are going to be pretty close, they're going to be clustered around each other. And of course, this is a non-exhaustive list. We assume a lot more things about data. Once you actually start thinking about it, I'm sure you can come up with many. And so, why am I talking about this? Why does this matter? Why does it matter that we have all these assumptions about data? And the reason it matters is that we don't just have data to have it. We use data to make decisions. And some of those decisions are life critical. So a child's age is an important factor to consider when you're looking at emergency placement options for a child. And the emergency placement options that you might consider for an infant are totally different than the ones that you would consider for a teenager. And so the upshot of that is, in child welfare, for example, when time is of the essence, we want caseworkers to have the right information at their fingertips, right? So this is why this matters. And the broader theme is that, we owe it to ourselves to be explicit about our assumptions, and that should include our assumptions about the data that we use to drive our decisions. So what are the important problems here, right? So I'm like, okay, I'm on board. I'm like, right. I'm like motivated. It's really important for me to be explicit about my assumptions. Where do I, how do I sort of come up with my assumptions? So we're usually doing that when we first get a data set. We're in our initial analysis phase. This is when we're spending the most time with a data set. We're exploring it. We're trying to figure out what we want to do with it. We're learning its quirks. We're maybe changing it in various ways. And we learn a whole bunch about it. We, write some models, we write some applications, like who knows what we do with it. And then we don't really look at it again, We built up all those assumptions. We got our data working for whatever we wanted to do. And then we moved on to the next thing. And rarely do we write those assumptions down. And so the reason that that's a problem is that data are always changing. So a really common way that data change are that you simply get more data. But I think we've all probably encountered data schemas change. Another interesting way that data can change are if the sort of panel that the data are coming from, it changes and grows over time. Your sensor might get upgraded. It might get replaced with a completely different sensor. Or, your data vendor might expand to like a new geography of the world. So all of a sudden you've got like a new country that's sort of contributing data to your data set. Related to this problem is that some of these changes are going to be really loud. They're going to break your ETL processes. They're going to break your scripts. They're going to tell you like, hey, like I am data. I have changed. Your stuff doesn't work anymore. Those are really friendly and like really polite failures because they announce themselves. There are going to be other failures that are just going to totally slip by you. You're never going to see them coming. A really common one is if you have a categorical variable and levels of the domain of that variable get added or dropped. That's a really, really hard thing to catch. It's not a loud failure. Another one is just that your data never arrived. So we're like, data are always changing. We have all these assumptions about data. We're not good about, writing them down and validating them. And part of that is that like manually checking data is like difficult. It's inconsistent and it's error prone. Like you have to remember to do it. You have to remember how to do it. And that's hard enough with just one data set, but like imagine you're working with tens of data sets or hundreds or thousands of data sets. And imagine that not only are you working with thousands of different data sets, all of those they're like completely different kinds of data. And so you're constantly trying to context switch between what are my important assumptions about all of these data that I'm trying to work with right now.
So, hello, I'm Leif. I work with Jane. I'm not a data person, I'm a software person. And so Jane and I were talking about this, and we started thinking maybe we want to try to build something to solve this problem. And so we started writing down what are the things that we actually need to get done to help deal with the fact that these data are going to change and might no longer, our assumptions may no longer hold in the future, and we want to sort of know about that. So we want to take our assumptions and write them down in a way that we can evaluate them automatically. We don't want to have to, like, writing down just the words, we don't expect children to be older than their parents is not enough. Like, we could give that to a person and they could recheck the data every day, but we want a computer to do this for us, and to do it in the same way every time. And then the rest of it kind of falls out. We want to take the specification that we wrote and run it every time we import new data or update old data. We want to get a report when something that we thought was true is no longer true. And this is a minor point, but we want to report everything, all of the assumptions that didn't hold, not just like the first one. So you can imagine putting this into like a data ingestion pipeline. You don't want to just stop at the first one. You want to see everything that was going on that was weird, so that you can go do something about it. And so what we asked was, can we write like unit tests for data? Because I'm a software person and I like testing my code. Can I test my data? So we pulled out unit test and kind of started playing with it, wrote some tests, and started evaluating, like, does this work? And it pretty much does. So each test method can like load in some data and then compute some fact about it, like how old are all these people in our database. And it can say, they should probably be less than 150 years old. We can write that and have a computer execute it. And then we can kind of just put this into whatever process is ingesting data. We can put it into a cron job. We can put it in front of our ingestion scripts or sort of after our cleaning phase of data ingestion, we can take these things and run them wherever we need. And unit test will run all of our tests and will give us a whole report of which failures happened. And so this actually this works pretty well. And you can pick sort of any unit test, or you can pick any testing tool. And mostly the feature that you're using is the test execution thing. Everything else is just the code that you wrote. We picked unit test because we work at a company with a lot of Java developers, and JUnit is familiar to them, and so unit test kind of looks similar. But you could pick any of them. So at this point, we want to kind of show you how this works, but we can't show you child welfare data. We also don't have it, and we also can't show you any of 2 Sigma's data. So we're going to take this public data set. There's a bunch of bike share programs in different cities. New York has City Bike. Boston has a bike share program called Hubway that when I was practicing, or when I was building up this talk, found out that they changed their name to Blue Bikes in 2015. Surprise. And if you go to their website, there's this is actually a link. It goes to some place in S3. You can download a bunch of zip files full of CSVs, and this is the schema of one of the records. So let's look at what's in here and then try and talk about what some assumptions might be. So we've got start time and stop time and how long the difference of those 2 numbers is. We've got information about how, where the trip started and ended. We've got some latitude and longitude, and those might be fun. We've got some kind of internal bike ID. I don't know what this would be, but presumably maybe they're unique. And I've got information about the person who took the trip. I've actually got their birth year, so we could do age stuff if we want. And apparently gender is 0, 1, or 2. I don't know what those mean. But, what's that? I mean, there's way more than 3 genders. Who wants to, come up with something? What might we assume about a data set like this? Anyone?
Stop time should be after start time.
That's a good one. Anyone else? You raise your hand.
Lat long is on the earth somewhere.
Should be on the earth somewhere. That's a really good one. Anyone else?
Near Boston.
Sorry?
It should be near Boston.
Should definitely be near Boston. That's a good one.
Yeah, in the back, in the red.
That would be Boston.
Okay.
Okay. So obviously, go.
Trip time should be cap on the distance between start and end.
Trip time.
Trip time or?
The total time for the trip should be an upper bound, or you should be able to use it to get an upper bound on how far.
Yeah, you can't bike at
Yeah.
the speed of light.
Exactly.
Yeah.
Okay. Yeah. So trip time was a really cool one.
Trip duration should be not negative.
Should be not.
Not negative.
Yes, correct. So there were no negative trips in the data that I looked at. There were trips that lasted over a month. I'm guessing someone just left the bike somewhere and someone came along and found it and plugged it back in later. But those are the kinds of things that you find if you start looking for failures of these things. But of course, so we want to show you how to test a data set like this, and we had to write the stuff beforehand because we don't type as fast as James Powell. So here's the one that we chose. We want to check to make sure that trips are not really far, because we get start and end points, but we don't get total distance traveled. The wheel doesn't have an odometer on it, but we can do point-to-point distance. And so we know all the stations are in Boston, so we know they should be less than the diameter of Boston for some definition of Boston. So how do you write a test for this? First, you have some kind of setup that we're omitting here. It's just open up a zip file, pandas, read CSV, whatever. Hidden in that ellipsis, use an ellipsis. Hidden in that ellipsis is we're also computing the distance. So given 2 lat long points, there's a formula. If anyone wants to look it up, you can. And you can find like the distance, and I'm computing it in meters here. And then the next thing you do is you want to write a test method that says what your assumption is and checks for it. And so first we're setting up some thresholds, and just to add a little bit of flavor, I didn't look up how wide Boston is, but a marathon, like the distance of a marathon is a little bit over 42 kilometers. And so we might say if someone bikes that far, like that's pretty crazy. But also, like even if someone just bikes a 10K, that's pretty interesting. I kind of want to see something about that too. And so then for each of these thresholds, we're going to check, were there any trips longer than that? And so here, if you're not familiar with pandas, it's pretty simple. We're taking the data that we read up in the setup script, or the setup function, and we're finding the subset of it where the distance traveled is larger than this threshold value. And so long trips will be a new data set that is just that subsample. And then we just assert that the number of trips that were that long is empty. So what does this give us? It fails. So cool. So the thing did what we expected it to, which was to detect when there were trips that violated the assumption that they're not very, very long.
So as we mentioned before, we can take this test that we wrote, we can schedule it in a cron, and our question might be, okay, like what does this give us now? So the first thing is that all our new data are automatically tested for long trips, where long trips is longer than a 10K or a marathon. We don't have to remember how to test for long trips, right? We wrote it down and it's executable. And another thing that's pretty interesting is that we can easily run this test on historical data. So not just sort of data on the future, it's very easy to take a test method like this and run it over all the data you've accumulated up to this point. And so what we can do is we can take all of the other assumptions that everyone in this room came up with, and we can write test methods for all of those as well. And we're in a pretty good spot at that point, right? You know, we've thought through our assumptions about the data. We've made them explicit by writing them down, and we've made them executable by writing them inside test methods. We've automated them, and I think we get a gold star.
Dun, dun, dun. So cool, set all these things up, they run, and nothing fails for a while until we get this failure again. And because this is months away, and we filled in the rest of the OWL, and we wrote all the other tests, Jane sees this and can't remember what false is not true means, or why I care about long trips. So she asks, is there a way to see local variables in my unit test output? And I said, I think PyTest does that, which is a really funny story if you go read the Marbles docs later.
So I originally asked, is there a way for me to see local variables in my test output? But the more I thought about it, the more I realized that there was actually a lot of information that I was missing. And it wasn't just the local variables that I was missing. So I'm looking at this test failure, and some of the questions that come to mind for me are like, what is this test doing? And like, why is it here? Another really important thing is like, what am I supposed to do about it? It's like, okay, you found long trips, like, and? You know, do I delete those long trips? Do I re-download the data? Another thing that I can't really tell is like, how bad is it? Like, was the trip, 1 meter over a marathon, or was it like orders of magnitude? Did someone bike like several marathons? I can't tell. And also, people that work with data, this is probably going to be a pretty familiar one to you, is you're like, okay, have I seen this kind of behavior before? Have I seen this shape of problem before? And like when? Because that past experience is going to inform what I'm doing right now. And the grand theme here is that this context is really expensive to recover. So I knew all of these things when I wrote that test. And yet when months go by and this test starts failing, that failure message doesn't show me any of that information. And so this problem of, that like context is expensive to recover, this isn't unique to data. Like we also have a problem, with software unit tests. Like it can also be hard looking at a test. You're like, what the hell is this doing? I completely forget what this was doing. I didn't even write this thing. But it's especially hard with data, and it's especially hard with data for a couple of reasons. And the first is that our assumptions about data aren't often a clear-cut black and white yes or no. But in order to encode it into a test, we have to translate our assumption about the data into sort of like a binary pass-fail that can be evaluated. And we do lose, when we make that translation from our sort of vague expectation about the data into a binary pass-fail, we lose some information about what we were thinking. The second is that failures in data are usually introduced by someone else. So this is different than software unit test failures. So a really common way that software unit test failures start failing is like you're working on a code base, you're making changes to the code, you're running the tests, and all of a sudden something breaks. But you are, you're in there like mucking around in the code, so you probably have a really good idea of what changed to sort of cause the failure that you're seeing right now. But we don't muck with data like that. We don't, hopefully. Hopefully we're not doing that. We really don't mess with data like that. Often data failures are introduced, by some sort of upstream, some process upstream of you, some sort of ingestion transformation process. It might even be outside of your organization. It might be something that your data vendor is doing. And what this means is that you probably have little to no insight, not only into what changed about the data, but who did it and why. And finally, this is another thing that sort of distinguishes data unit tests from software unit tests, is that the follow-up is different. So when a test starts failing, it's pretty natural for your first thing to be like, okay, how do I get this thing passing again? So I could get my test passing by just removing the long trips, but like, we can't just go around destroying data. Like you can't really do that. And so the follow-up might be that I need to go talk to, it might be that I need to like pop open the data set and like, look at these lat longs and like look at this try to find the trips that are really long and see sort of what's happening. And it might be that I need to go talk to the data vendor or whatever. That follow-up pretty straightforward. But again, imagine, I have like thousands of these tests, and each of them might have a different sort of follow-up. For one of them, I might need to pop open the data. For another one of them, I might need to call a vendor and yell at them. It could be totally different. And I'm trying, and how am I going to, keep track of all of that information? And so I actually found myself in this situation. I actually found myself having this problem. And I looked at Leif and I was like, is there a way, I knew all of this stuff when I wrote this test. Is there any way that I could recover it all in the failure message? And so we wrote a thing.
So essentially, we wrote a thing which is an extension of unit test that does some subtle things to allow you to carry this context forward. And there's a way that you use it, and we'll get to that, but what I want to show first is what you get at the end. So what does the message that you get look like, and how is it different from what you normally get out of unit test? Some of these things are going to be familiar if you've used other test runners. I think some are not. So this is what a failure looks like in Marbles. This is running the same test that we saw before. And there's a couple things that you'll see. And the first question that we were asking about the old failure message was, what is this test doing? And so Marbles will give you those local variables that we talked about that PyTest does in a slightly different way. And when we look at that, we can see what the state of the test was at the moment that it failed. And this is slightly edited. The data frame is a lot wider. But we can see the stop station latitude is 0.0, which probably means a sensor was wrong or someone messed up some null handling or something along the way. But this bike trip ends at what Jane refers to as Nowhere Island, which is somewhere off the coast of Africa at 0, 0. We can also see a little bit more of the source code to maybe refresh our memory about what this test was. There's a really annoying thing about Python tracebacks that if your function call spans multiple lines, it only shows you the last line, which is often just like a closed parenthesis. So we did AST tricks to make that work. And then to answer the question, why is it here, we added this note field that's really just like a free-form text field that it'll do like format string stuff, so it'll be easier to work with, but you can write all the context that you want in here. And so here, like, why is the test here? Well, it's saying there are some long trips. And what should you do about it? Well, like, go check if these trips actually happened. If someone did like bike this far, I don't know, call the news and say like, look how great our bike share program is. Or if they're not, like go fix the bikes or fix your data ingestion. And then to answer how bad it is, you can capture that kind of in the note. You can also kind of use the local variables to expose some of this information. And we'll get back to like how to choose what you display and how to write your tests a little bit differently when you're doing this kind of thing. And so we started using this and started seeing these failures come back and found ourselves looking at that section of source code pretty frequently and realized we can actually add more context there. So for that, we added what we're calling semantic assertions, which is like a functionally separate thing, but we package it together with the rest of marbles. And so we noticed that we were seeing people write things like this somewhere in their tests. And then other people would write things like this. And evil people would write things like this. So like, who can tell me what each of these people are trying to do? Just shout it out.
Between.
Right, so we thought we'd rather see this. And essentially what we are doing here is capturing like, what did you mean? Not like, how do you check it? So what I wanted to say is that X is between the lower and upper thresholds. And so this is like not rocket science at all, but it ends up actually being really powerful. So we have a set of mix-ins where, sorry, I don't need to touch, I have code highlighting. We can change the test that we've got up here by mixing in an additional class that adds these extra assertion methods to your test case. And then you just sort of call them down there. And you can mix in a whole bunch of different kinds of things. These are the ones we've got so far. We would like to see more. Some of these actually are just like straightforward renames. So like a lot of the file mix-ins will be like, we'll actually just call down to a regular expression assertion, but just like have a different name, which is useful when you're looking at the test. But so if you have ideas for things, like send us a pull request or an issue.
So just to reemphasize what Leif said, like this is absolutely not rocket science. Like a lot of these semantic assertions just call down to lower level familiar unit test assertions. We didn't do anything fancy to make them, and you can definitely write your own. If you look at the Marbles mix-in source code, it should be pretty obvious to see how you might start writing your own assertions. And one reason you might want to do this is if you want to enforce that sort of everyone on your team or everyone in your organization is asserting a sort of like business requirement in the same way. So in the test case example we've been using so far, we've been asserting that a subset of a data frame is empty. We've been using the empty attribute on the data frame to do this, but someone else at our organization, might do it like looking at the length of the data frame and making sure that it's 0. And so what we can do is instead, to make sure that we're sort of in sync and we're all doing things in the same way, is we can write our custom assertion, and obviously its implementation is going to use the way I did it instead of the way someone else did it. And then what we can do, this is sort of like a silly example, but what we can do is if we ever need to change, for whatever reason, for some business reason or whatever, if we need to change the details about like the implementation details about how this assertion gets made. Everyone using this assertion can sort of pick up that change. We don't have to go hunt down the people that are using dataframe.empty. We don't have to hunt down the people that are looking at the length of the data frame. Okay, so we've come pretty far into our talk. I was looking for all of this information. I was looking for all of this context. I didn't want to lose it. And how did we do? So again, the first question that I wanted to answer is what is this test doing and why is it here? So I'm seeing the source code. I'm seeing the local variables. I'm not looking at a traceback and I'm looking at a semantic assertion. I'm not looking at just assert true. So I think we get to check this one off. What am I supposed to do about this failure? So that annotation can contain that information. If I'm diligent about writing down that information in the moment that I'm writing the test, I'm going to help myself in the future. Oh, sorry. Thanks. How bad is it? Again, the local variables sort of show me what was the state of the data at the time it failed. What are the records that are sort of tripping me up? And then the last question I had was, have I seen this failure before? And if I have, when have I seen it? And that's the thing, we haven't quite done that yet.
So we added a little bit more. And what we did is essentially we added something that will log every time you make an assertion. So every time you call the assert function, it will dump out some information. And you can save that somewhere and go look at it later. And now it's a new data set that you can explore and analyze. There's a couple ways to turn it on, and you can look at the docs. And I think the docs for this actually need to be improved, but they're OK. So you add a little bit of stuff, and you get a sequence of JSON blobs like this, which contain name of the test case, name of the test method, what was the assertion you made. We copy in the local variables, and we have a kind of odd schema for this, which is a list of dicts with key and value. This is because internally we're using Elasticsearch, and it has a wonky data model, but don't worry about it. You still get the same values out. And then down here, we can add a little bit of extra information. So when we actually configured this to generate this example, I configured the logging to sort of log month, severity, and anomalies as separate fields, because these are the things I'm going to want to look at later, because this is a time series data set. And there's a couple other things in here that are not interesting enough for a slide. So have we seen this kind of problem before? We can take our months of logs of these assertions that we've stashed wherever we've stashed them. Hope it's not Elasticsearch. And we can generate plots. And so we can say, let's say we got a failure in September, and we want to look at what's happened in the past. Well, we've had some kind of 10K rides. Most of those maybe were legitimate. It looks like there's sort of an upward trend recently. We're getting into summer. Maybe our bike share program is really taking off and people are going to the beach. And then we can also see something happened in October last year. We got a lot of trips to Nowhere Island. And maybe we go back in our emails and look for, did we figure something out? Could this be happening again? That kind of thing. But also now your logs are just another data set that you can analyze and do whatever you want with. So you can do aggregations and you can do reporting and go wild. I don't know. We've done some things with it, we do sort of reports and dashboards, but you can imagine doing other things.
And so like I mentioned before, this context, sort of preserving all of this context and preserving all of this information, this isn't unique to data. And it's actually really valuable for software unit tests too. We're getting really, really close to the end, so I'm sort of going to run quickly through the rest of this. But this is let's say I'm working on a code base, I'm making a change, and I run the test, and I get this failure, and I'm looking at it, and I'm like, what? Okay, I didn't write this test. I don't know what it's doing. we run this under marbles, all of a sudden I can see like, oh, I see what this test is doing, and I also see that this is like a really bad test. When we realized this, we realized that it was going to be really, really important. One of the things that we wanted for marbles was we wanted people that had just like software unit tests to be able to recover all of this information and all of this context too. So if you have existing unit tests, you can run them under marbles without changing any of your test code. So all you have to do is pip install marbles, and then here where you would normally say python-m unit test, you can say python-m marbles, and you'll get that marbles failure message.
And now it's the end of the talk, so standard things. There's GitHub. You can go there, look at the code, send issues. We've got pretty good documentation. It's also linked from there. One particular thing about the documentation, it's like partially about like this is what marbles does and how to control it, but also there's a bunch in like a section on like how to win at marbles, which is how should you use these features to write more effective tests that are like better to receive failures from. So there's like a lot about like how do you choose which things you put into local variables. There's like you can prefix things with an underscore to hide them if they're really large, that kind of thing. Use the issue tracker if you have like bug reports, feature ideas, specifically like ideas for new kinds of mix-ins. If you notice anything weird with the documentation, or if you just want to ask questions, this is a good place. Well, that's it. Thank you. It's 5:40, so you should all go if you want to, but we will stick around and answer questions. And as people are filing out, if anyone wants to raise their hand, we'll answer for everyone. Yes?
So I looked at lots of data, and I used to receive vendor data at previous positions. And one of the things is that sometimes when we get failures on our unit tests, we have to make the decision whether to pass it, to fail it, or to override or fail. Is that something that you adding in is like some way to say, okay, for this data set, these all failed the test, and I have to override these, or something like that?
So that's at kind of like a separate layer. So marbles it's at the layer of like I'm writing all my tests down and I'm like setting them up to fail. So we can layer things on top to sort of catch the failures and, for example, like maybe have them automatically create issues in like some sort of like support tool that you're using. But another thing that you can do is like, if you don't have like a support layer like that, where you can sort of go in and say, okay, yes, this is fine. No, that's not fine, whatever. You can put that information in the annotation. If you're in a little bit of like a more, is brass tacks? Is that a correct usage of that? I don't even know what that means. You can also use that annotation to say, here's where you go to clear this. Here's where you go to fail the entire data set. And maybe you can put anything in that annotation string. It's just a text field. So you can actually put like commands to run. You can put links. Like you can put anything in that annotation. Yeah. Go ahead.
Okay. So like the workflow I often use is CI/CD, and it sounds like what you're saying with marbles is that it could be used as kind of a last gauge before CD. Like you have production data coming in. I was curious if you had any ideas about like whether marbles would have any place in continuous integration, like in a GitHub hook on like a pull request build or anything like that. Like in that stage, would you still be mocking, having test data, stubbing data, or would you ever have a situation where you would use marbles to validate data before you're actually in deployment in the integration stage? My question might not be clear, but.
I think the answer is yes.
Does this mic work? Oh, it does. Okay.
So it's like for questions.
Cool. Leave him with the handheld one, and we can.
So I think, yeah, you should definitely do that if you want. I mean, the tool is just a test runner. Like it's more friendly, but it's fundamentally like not really any different. So anything that you're using to run tests in like a CI/CD system, you could run Marbles tests too.
I think the question that you're asking is more on like a data sort of operations strategy question, which is like, when in our data set lifecycle do we need to be asserting these sorts of things? Luckily, Marbles, it's like based on unit tests, it's like it should be pretty easy to run it sort of anywhere in that lifecycle, wherever you decide to put it. I don't think there's anything about it that would prevent you from sort of placing it at a particular spot.
Yeah, okay. I was just trying to talk about like, you would generally not want to bring in production data like before you would really want. So like there's some threshold there of test data and the test runner to finally using production data and validating that and continuing.
Yeah, so like one thing specific to Marbles that you could do is you could set your thresholds so that like something that's not very severe would like be okay, like wouldn't fail your CI system if it were running on test data, but would fail if you were running like the prod like pre-deployment step. And like you can tag your tests with like, this is critical, this is not, that kind of thing, and like differentiate there. But otherwise, yeah, I think it's like an organizational strategy question.
Another question.
Yeah, I think we had.
Yeah, you want to do a question?
It looks like you're supporting only unit tests today. Have you looked at the other PyTest functional test, doc test formats? Are those anything you're looking at supporting?
We've definitely looked at all of them a lot. So there's a section in the docs explaining the difference between sort of Marbles and PyTest. Like my initial response was, yeah, I think you can use PyTest to do that. But then like when we really dug into the problem, we realized that it's solving a different problem. And of the other test runners, like doc test is testing about documentation.
No, actually, I want to use Marbles on my PyTest functional tests.
Right.
That's the other side of I see the value.
So that,
Thank you.
sorry, that's cool. We've looked at that, and it's really hard. Like the way that we make this work is hooking into some internal stuff in unit test, and like redoing that in PyTest would be, I don't know how you would do that. The other thing about PyTest is like, its style is to encourage you to use the assert keyword, and it's kind of unclear where you would put a note in if the note thing is what you're looking for. It's unclear where you would put that in inside like the test body. And like some of the other things that Marbles does, like showing you local variables, PyTest like does something similar too. I think there's a flag you set. But so like some of that is already kind of captured.
Yeah.
I do have to give closing remarks, I believe.
I'll stay and hang out.
Maybe Leif will stay and hang out. Thank you all for
Thank you all for coming along. Give a round of applause for Jane and Leif.